Chapter 2 of class 11, that is structure of atom. This video will comprise of 4 parts. What is an isotope, isobar, isotone, isoelectronic species. Plus we'll also study about what is mass number and atomic number. We'll do a few examples, so this video will be based on this only. So first let us understand, what do you mean by mass number? You take this is sodium, right? We all know that it's sodium, Na. Here I'll represent as 23 and 11. Now what is this 23 and 11? 23 is known as the mass number, okay, and 11 is known as the atomic number. Now what is this mass number? Mass number means it is number of neutrons plus protons present in an element. Atomic number means it's just the atomic number. Atomic number is represented by Z. Now if they ask question number 1, identify the number of electrons, what will you do? Number of protons and number of neutrons give you mass number. That is why what we'll do here is we'll subtract number of neutrons. To find number of neutrons, number of electrons we'll be finding out, right? So to find number of neutrons, we'll subtract 23 minus 11. That is mass number minus atomic number. What will get 23 minus 11? 12. 12 will be the number of electrons. Identify the number of electrons or state the number of electrons. Identify the element, state the number of electrons. It will be 12. Let's take another example. Carbon, we know carbon is an element. 12 and 6. Mass number, this is atomic number. Identify the number of neutrons or state the number of neutrons in this. 12. Protons, same answer, 12. What about electrons? If they ask about electrons, you are supposed to do 12 minus 6, which gives you 6. This tells us about number of electrons, neutrons, protons, mass number, atomic number. Is this done? Yes, it's done. Moving on to what is an isotope, isobar, isotone and isoelectronic species. So what is an isotope now? Isotope means they are atoms of same element. Isotopes are atoms of same element. Atoms of same element. Number 1, atoms of same element. Number 2, with same atomic number. Number 3, different mass number. What is this number I'm saying? That means point, okay? Different mass number. This is an isotope. Atoms of same element, same atomic number, different mass number. When you take their examples, you can take example of carbon and carbon. Okay, this is 12. Here also, here it will be 14, 6 and 6. Mass number, atomic number, mass number, atomic number. See, same element, correct. Same atomic number, correct. 6 and 6. Mass number 12 and 14. So that is an isotope. Now in this case only same thing we'll write for isobar. In the case of isobar, it will be atoms of same element again, okay, atoms of same element, but what will be different here? It will be different atomic number, okay, and same mass number. Let's take example for this one. Here we have example. Let's take example of hydrogen and hydrogen. One, let it be protium, and the other one deuterium. 1 and 1. Here it will be 2 and 1. See, same element, different atomic number, same mass number. Now we need to know that the element which has 2 as its mass number is known as heavy hydrogen. It is known as heavy hydrogen. Okay, it is known as heavy hydrogen. Why do isotopes have same chemical property? If they ask you this question, you need to know that because they have same number of valence electrons or because they have same chemical property. That's why an isotope have same chemical properties. Same chemical properties, so same number of valence electrons. That's why isotopes have same chemical properties. That's all for here. Protium, if they ask which, for protium, this is protium, okay, they'll ask which is known as heavy hydrogen. So you need to write the name, that is protium. What is an isotone? Isotone means same number of neutrons. They have same number of neutrons. Okay, that will be isotone. For example, take carbon and oxygen. Here we'll give 14, 6. Here we'll give 16 and 8. Okay. So how will you find out the number of neutrons here? 14 minus 6, whereas here n is equal to 16 minus 8. 8, 8. See, same number of neutrons, resulting in the same number of neutrons. But I did teach you how to find neutrons. Subtract 14 minus 6, 16 minus 8. Now what is isoelectronic species? Iso, as the name suggests, same number of, very good, what? Same number of electrons. Yes, let's take few examples, or only one example, no few examples, N2. How will you find out the number of electrons? Carbons, this thing is 6, 8, so 14 electrons. N2, 2 into nitrogens, this thing is 7, so 14. See, 14, 14, same number of electrons. Hence, we come to the end of this video. We have already classified what is isotope, isobar, isotone, isoelectronic species, and also we learned about what is mass number, atomic number, how to find number of neutrons, protons, and electrons when an element is given. Right? So, we'll go ahead with a short recap of this video. How to find, this is the element, 23 and 11. 23 is the mass number, 11 is the atomic number. We found out electrons, we found out neutrons. Then we learn what is an isotope. Isotope means atoms of same element, same atomic number, different mass number. Isobar, atoms of same element, different atomic number, same mass number. This is known as protium, that is known as heavy hydrogen. Isotone, same number of neutrons. We took two examples. We subtracted their mass number with their atomic number. 14 minus 14 minus 6, that is 8. 16 and 8. 16 minus 8 is 8. Isoelectronic species, name same number of electrons, that is isoelectronic species. Hence we come to the end of this video. Please tell me what more will you like to learn about this chapter. In detail, I'll be explaining each and every lesson. Chapter 1 we'll do at last because it's a long chapter. Okay, so every video will be coming every Friday or every Saturday. Please do tell me in the comment section about how you like this video. What would you like to learn more about this lesson? Comment, share, subscribe. Thank you.